Hello everyone and welcome back after a long time. And from today we are starting a new series of video lectures of UPSC Civil Service Exams mains paper solution of mechanical engineering. So in this video series we will solve some questions of UPSC Civil Service mains exam of mechanical engineering. Okay, and in this video series, in each video there will be one or two questions based on the length of the question there will be there, and this in this series we will solve last 3 years papers. Okay, last 3 years of paper, that means the recently conducted 2021, 2020 and 2019. Okay, so without wasting any time, let's start our today's and this video series first question, that is uh, based on the machine design, or you can say the strength of material also, and we can consider as a machine design also question. So the question is, a solid circular shaft subjected to bending moment is 2500 Newton meter. So I have designated with M, so 2500 Newton meter, and torque also 8000 Newton meter. Ultimate tensile strength, that is sigma u, it is given as 700 megapascal, and ultimate shear strength tau u, it is also given as 500 megapascal. Okay, and factor of safety is also given, that is 6. So first of all we have to find the working stress, working tensile stress, that is 700 by 6, it is turn out to be 116.67 megapascal. Okay, and working shear stress, that is 500 by 6, that is 83.33 83.33 megapascal. Okay, put just keep this value aside. Now we have to find the diameter of the shaft, and the unit should be in mm. Okay, here unit is not mentioned, but generally we will find in mm. So here you can see the shaft is subjected to simultaneously bending as well as torque, bending moment as well as torque. So first of all what we have to do, we have to do the two cases here. We have to find the equivalent bending moment m equivalent and equivalent torque as well, and we have to solve this problem in two parts, and whatever the diameter comes, and we have to finally select based on the our strength criteria. So what is the equivalent bending moment equation is given by 1 by 2 m plus under root m square plus t square. Here we know the all the value, m is equal to 2500, t is equal to 8000. So if we put all the values and calculate in the calculator, so we will find out that equivalent bending moment is 5440.76 Newton into meter. Sorry, Newton into meter. And equivalent torque, it is given by under root m square plus t square. So if you put this value, and you will find out 8381 Newton into meter. Okay, so this is the equivalent torque and this is equivalent bending moment. Now what we have to do is use the flexural for equation formula. M by I is equal to stress upon y, where y is equal to distance from neutral axis to maximum stress, and torque equation, torsion equation, T by J is equal to tau by R. So I by Y, we know the section modulus I by Y, and which turns out to be pi by 32 d cube. We all know that. And the polar section modulus ZP, that is Z by R, which ultimately turns out to be pi by 16 d cube. Okay. Now put all the values here. Bending moment M 5440.76. Here it is Newton into meter, but we want our answer in mm, so multiply with 10 power 3, and I by Y section modulus, here it is pi by 32 d cube, and working stress is, we know the working tensile stress is 116.67, so it will be 116.67 67 megapascal. So now whatever the answer you will get of diameter, it will be in mm. Okay, so if you solve in calculator, so you will find out that diameter is turn out to be the all nearmost integer value is 78 mm. Keep this result in a box and now solve for torque. So torque is given by 8381.52 multiply by 10 power 3. Why? Because we want our answer in mm and torque is in Newton into meter. So we have to convert meter into mm. So multiply with 10 by 10 power 3. And polar section modulus is pi by 16 d cube is equal to torque is what 83.33 megapascal, working shear stress 83.33. Now if you solve this equation, this formula, so you will find out diameter is 80 mm, the nearmost integer value. So put this here. Now we have two diameter. Now we have to decide which diameter we have to choose. So here we will choose the diameter 80 mm. Why? Because if we choose 78 mm diameter, then our shaft will be sustained out in bending moment, but the shaft will fail in torque. So to prevent the failure of shaft in torsion as well as in bending, we will use, because if you use 80 mm diameter, then it will definitely sustain in bending stresses. So and 78 mm it will fail in torsion. So our answer will be 80 mm diameter, the shaft diameter that should be used. And in actual exam you have to write a conclusion mark that the here after the calculation we have found that 80 mm diameter is suitable, and the reason is it will sustain in equivalent bending as well as torsion moment. So this is the answer. I hope you like this solution, and we will meet in the next video and with next question and their solution. Thank you for watching this video, and subscribe this channel for continue this series.